Hello. Now we're going to look at the idea of using symbols in maths, so the beginnings of algebra. So we're going to start with a story. We walk into a shop to buy an apple, and we give the shopkeeper, so we grab our apple, and we give the shopkeeper a €5 note, and they hand us back €4 in change. How much did the apple cost us? Now, instinctively, you know the answer is €1. But we're going to look at how we can use symbols to describe this situation. And this is the beginnings of algebra, because if we can start to describe simple situations using maths language, using algebra, then we're going to be able to build up to describing very complicated situations that we couldn't figure out any other way. So we're going to start off with things that we can just do in our heads, and we're going to learn the language of algebra in that context of simple situations. So let's talk about it again. We handed in €5, and that must be the cost of our apple. So what would we call the cost of our apple? Well, apple starts with an A, so I might call it an A, plus €4. So the cost of the apple plus €4 that we got in change must be the total, must be the €5 note. We got an apple and we got back €4, and the overall was €5. So this is how we can describe this whole story in a single line using mathematical language, using a symbol. The symbol here is the letter A, which stands for the cost of one apple. So this is how we can translate from a big bunch of English into a single line of mathematical language. And this is, again, our algebra. This is where we're starting off with our symbolic use of maths, using symbols in maths. So, cost of the apple plus our €4 adds up to the €5 that we started with. And then what we can say, for now, we will look at the structure of how it is you solve this type of equation. So this is an equation. It has an equal sign to begin with. So it's called an equation. We are going to look at how to solve these more formally in a little while. But for right now, we want to just build up an understanding, a feel for how this is going to work and for what the value of A should be. So we know from just reading the story that A is going to be €1, but can we see it here? Well, we know that 5 is something plus 4. The something we know logically just for now must be 1. 1 plus 4 is going to equal 5. So A must be equal to 1. And specifically we can say A would be equal to €1, so that we're linking back into the way we were describing our story. So this is where we are at right now. We're going to get comfortable with the idea that our letters or our symbols can stand in for a number. And that's really what we have to get comfortable with right now. So we don't have to use letters. Usually we will, but we could also use symbols. So this is, to the best of my ability, a square. So some number that I've drawn as a square plus 3 is going to give me the number 10. So a number that I'm using the symbol square for plus 3 is equal to 10. So what number plus 3 would be equal to 10? As I say, in the long run, we'll learn a more formal way of showing how we get this solution. But for right now, we want to understand that our symbol can stand in for a number. And in this case, we can see that the number has to be 7. 7 plus 3 would be equal to 10. So logically, the square must be standing in for the number 7. That's the only thing it could be. There's no other number, or the square could be, that would mean that the number plus 3 would give me 10. So the square must be 7. Now, what does triangle have to stand for? Well, we start with a particular number that we've called triangle. Minus 6 is going to equal 12. So what number minus 6 would give us 12? And the number must be 18, because 18 minus 6 would give us 12. So that tells us that the triangle must be 18. It must be the number 18. So we can use our symbols to stand in for numbers. We've seen it in this story, and we've also seen it with our square and our triangle here, that we can have a symbol stand in for a number. Now we're going to add a little bit of English into the mix. So we're going to start off with something that doesn't involve algebra, just getting used to the language. 5 greater than 7. What number would be 5 greater than 7? So we start at 7 and we want to go 5 greater than it. That means we're going to go up 5 units from there. So we're going to add on 5. We're going to go 5 places up from 7. We're going to get 5 greater than 7. And when we do that, we're going to get 12. So that's how we can interpret our language. 5 greater than 7 would be 5 units bigger than 7 or greater than 7, which means we're going to add on our 5. And we have to be able to take that, understand the English of this, and translate it into what that would mean mathematically. So how could we do this one? 3 less than x. So we start at x and we want to go 3 less than that. Whatever number x is, we know that x can stand in for a number, but we don't know what it is in this case. We don't have an equation. So we start at some number x and we go 3 less than it. Well, how would we go less than something 3 spaces? We'd subtract 3. And that's as far as we can go because we don't know what x is in this case. We can't find out what it is like we did for our apple. We don't have an equal sign. But this is a perfectly fine answer. This is a number minus 3, or a number less than, or 3 less than a number. Next, 8 multiplied by 3. So 8 gets multiplied by 3. And we know we use brackets for multiply when we're using our numbers. So 8 multiplied by 3 is going to give us 24. And that's the job done. So we've translated from English to maths. But what happens here? So we have 2 multiplied by the letter k. And again, k is standing in for a number, but because we don't have an equal sign, we don't know what that number is. So it's going to be 2 multiplied by k. Now, when we were multiplying with numbers, we couldn't just write down 8 and 3 next to each other, because 8 sitting next to 3 has a meaning. It means the number 83, which doesn't mean 8 multiplied by 3. However, so that's why we needed our brackets. However, here, if we write down 2 sitting next to k without any symbol in between, that's not going to get confused for something else. So this is the short way of writing multiply when we have letters involved. We don't need to put in a little x. We know we don't use x for multiply anymore. And we don't need to put in brackets because 2 sitting next to k couldn't get confused for a number, for anything else. So a number sitting next to a letter means multiply. I'm going to write that in. So this is a big important idea that we need to get used to in terms of our notation for our algebra. A number sitting next to a letter means that the two of them are multiplied together. And this is something we just have to get used to. We'll get a lot of practice doing this and we will eventually get used to it. So here is an example of exactly that. We have 4 sitting next to x. So what's that going to mean? That means 4 is multiplied by x. If I wanted to write it out the longer way, I could put brackets around it, but I don't need to. So we're used to having to put brackets around it. We don't need to in this case because we know this fact now that a number sitting next to a letter means multiply. So let's think about this. Now this is an equation. I'm going to be able to figure out what x is because I have an equal sign at the start. So 4 times a number x is equal to 12. Well, what must that number be? 4 multiplied by what would give me 12? Well, for right now, we don't know the formal way of solving it, but we do know that 4 multiplied by 3 would give us 12. And that's the only number that would work. If I put in 2 or 10 or something like that, it's not going to equal 12. So the only value that x could be is 3. So x is equal to 3. Now here I have the number n, the letter n, which is standing for a number, divided by 3 is equal to 10. So again, this is an equation. It has an equal sign at the start. So I can find the value of n. So n divided by 3 is going to be 10. Well, what number divided by 3 would give me 10? That would be 30 divided by 3 would be 10. That means n must be equal to 30. And finally, 6 minus m would be equal to 2. So what number must m be? Again, this is an equation because we start out with an equal sign. So 6 minus something is equal to 2. And we think about it and we say, well, 6 minus 4 would be equal to 2. And that tells me that m must be equal to 4. And this is how we start our journey in algebra. We can see that we can have letters or symbols standing in for numbers. And if we have an equal sign at the start, then we're going to be able to find out what that number is, what the letter stands for. But sometimes we won't, and that is okay too. We can have answers like x minus 3 and 2k as our final answer. And if we don't have an equal sign, that's perfectly fine. And that's what we need for now.